Section 7.1 is about power functions. So first we're going to take a look at the graphs of power functions, and then we're going to look at some of their properties. So some terminology before we get started is if I have x to the n, then x is the base, where n is the exponent, and the entire thing is the power. So words you should be familiar with, but just a good review. So let's take a look at the first and second power equation. So that would be y equals x to the first, which we know is linear, and y equals x squared, which we know is quadratic. So why don't you fill out a table for both y equals x and y equals x squared, and then graph it, pause, and then come back to make sure that it looks correct. So y equals x should look like this, a nice line through 0, 0 with a slope of 1. And y equals x squared quadratic is a parabola going through 0, 0, 1, 1, 2, 4, etc. So those are graphs you should be familiar with, but as we move forward, if we looked at y equals x to the third, that is cubic. So if I plug in negative 2 to the third is 8, negative 8. Negative 1 to the third is negative 1. 0 would give me 0. 1 would give me 1, and 2 to the third would give me 8. So if we plot that, your x to the third should look like this kind of S-shaped curve here. So that is known as your cubic function. It will always go through 0, 0, and it will always start in your bottom left and then curve up to the top right. So that graph is always in quadrants 1 and 3. Y equals x to the fourth then is going to be called quartic. So if I do negative 2 to the fourth, that would give me a positive 16. Negative 1 to the fourth would be 1, 0, 0, and then those would reflect over to be 1, 1, and 2, 16. So if we plot those points on an xy axis, that would then look parabolic. This graph would just be steeper, but it would still go through 0, 0, and 1, 1. So that would have the same ordered pairs in common with x squared, but then as you go further, then it would be a little bit steeper. Y equals x to the fifth will be our next one that we just call the fifth power. Any power after 4 is just known as the number power, so 6th power, 7th power, etc. So if I fill out that table, that would give me negative 2, negative 32, negative 1, negative 1, 0, 0, 1, 1, and 2, 32. So if we graph that one, that will again give us this S-shaped curve going through 0, 0, having 1 and negative 1 in common, but then after that being a steeper graph. So if we think about the pattern that we saw, all even powers are going to be parabolic, and all odds that are not 1 will give us that S-shaped curve. So if you're looking at the exponent, you'll be able to determine the properties based on that. So the properties that we should think about would be everything goes through 0, 0. Even powers would be your quadratics, so that should be familiar. Your domain would be all reals. Your range would be y is greater than or equal to 0. And then your symmetry would be reflection over x equals 0. Odd powers, if you kind of think about it, we're also going to have all reals for our domain. Our range is also going to be all reals. And this time our symmetry is not reflection, but it's rotation. It's a 180-degree rotation around 0, 0. So these properties will be true for all even and odd power functions. So sometimes it is nice to know those properties without even needing to graph it, just knowing what they would be based on even or odd powers. Some of the questions that will be in this section would ask you just to evaluate using powers. So 2 to the fourth would give you a positive 16. Negative 2 to the fourth would also give you a positive 16. But the opposite of 2 to the fourth would be negative 16. So you really want to pay attention to your parentheses and use your orders of operations to make sure that you are evaluating correctly. An application problem would sound like this. Suppose there are 10 questions on one advanced algebra test, and each question has 4 options. What is the probability of getting all 10 questions correct? So if I think about it, if I have one question with 4 options, that would be just 1/4. Well, then the second question would also be 1/4 for getting it right, 1/4 of the third, and then if I have 10 questions, I could simplify that just to 1/4 to the 10th. You could plug that in your calculator and get a percentage, but it'll be pretty small, so we can just leave it as an expression. The point negative 2, negative 32 is on the graph of an odd power function. What other point must be on the graph? So I sketched here an odd power function. That's your S curve. Negative 2, negative 32 is down here. So if I think about the symmetry, that would also give me this point up here, which would then be 232. If I wanted to know the equation for that, everything is in the form y equals x to the n, so what I need to do is figure out what exponent that needs to be. So I can plug in -2 and -32, or 2 and 32, to that equation, and figure out n should be 5, because 2 to the 5th is 32. So then your equation would be y equals x to the 5th for your final answer. Question D, if n is even, what is the range and what quadrants? So even is going to be your parabolic shape, so the range is y is greater than or equal to 0, and they are always in quadrants 1 and 2. E asks about an odd function, so there's your S-shaped curve. The domain of every S-shaped curve or cubic would be domain is all reals, and is always in quadrants 1 and 3. Question F, which graph has reflection symmetry? So reflection means it would be a parabolic function, which means it would be an even power. So we are looking for 3x to the 8th. That guy. And last question, something similar to letter C. The point -216 is on the graph of an even, write the equation. So if I plug in -216 for x and y, I would have 16 equals -2 to some power. So that power will be 4. So my final answer will be y equals x to the 4th. So that covers section 7.1.